Welcome to the TapRooT podcast. We're talking about equipment today. One of the biggest things that people miss when it comes to doing investigations related to equipment is the cost related to equipment downtime. They recognize that the equipment being down is a cost, but so frequently they don't look at repeat failures. They don't look at actually preventing maintenance downtime. They just replace it as quickly as they can. So today's topic, we're going to talk about why your investigations into equipment failures are bad and how to improve it. Mark, I'll start off with you. Give us a little history about why Equifactor exists and what was some of the background.
Okay, well, this is ancient history. This is back in the late 90s, and I had people tell me TapRooT doesn't work for equipment problems. It just doesn't work. And I'd say, okay, well, tell me your example then. And they'd tell me their example, and I'd work through it. And eventually we'd either find out they don't know why the equipment failed, which is sort of hard to find a root cause when you don't know, or they thought root cause was the element or the thing that broke. You know, it was a diode here, or it was a bearing there, or it was a coupling here. It was the root cause. And that wasn't the root cause. So they didn't understand what it was, or that was the main one. That was the main one. It was they didn't understand. So therefore, I had to figure out, they don't understand troubleshooting. They don't understand how troubleshooting links to root cause analysis. And that troubleshooting is giving you the information you need to put on your snap chart and then to define what the causal factors were. And maybe it was a piece of equipment broke, or maybe it wasn't the piece of equipment that broke. Maybe somebody, I'll say, broke the equipment. They installed it incorrectly, they maintained it incorrectly, they used it incorrectly, and so it was much more of a human performance thing as to the reason why it wasn't working. And it had some link to equipment because they were breaking equipment, but it wasn't what they thought when they started out, because they were looking for the diode, the bearing, the coupling that failed. And TapRooT didn't lead them to the coupling. And let me give you one funny example. This guy called me on the phone and he said, I can't find the root cause for this accident we had. And I said, well, tell me some more. Wait, did you draw a snap chart? And he goes, no, I don't need a snap chart. I just need to know, where is the elbow on the tree? We have this thing called the root cause tree that guides you to root causes. And he goes, where's the elbow on the tree? And I go, elbow? I don't understand. He goes, yeah, if we would have had an elbow, this accident wouldn't have happened. And I'm like, so where's the elbow on the tree? Because if we had the elbow, then it wouldn't have happened, so the elbow should be on the tree. And I'm just like lost. I said, okay, you got to walk me through this step by step. To make a long story short, they had, when this process went down, it built up a lot of pressure inside. You had to relieve that pressure to restart the process. Well, they had a manual way to do that where you pulled this lever, and the place where the pressure came out was right where you pulled the lever. So the guys knew to pull the lever and run. And this guy didn't run. But if we had an elbow so that the steam would go up in the air rather than shoot right at him, he wouldn't have got hurt. So where's the elbow on the tree? And I thought, this guy doesn't know what he's looking for. This is not root cause analysis. He wants to redesign the system, which is good. And eventually I said, is this the normal way everybody does this? Oh, yes. I said, there's a procedure for this? Oh, yes. I said, this is a procedure has been approved by management, and it says you pull this handle and then you run to get out of the way of the steam. Well, no, it doesn't say that. I said, is there a procedure that says you pull this thing? Well, no, there's not a procedure for that. It's just everybody knows it. And this guy knew it. So eventually what comes up is this guy had been doing some special project for almost a year. And this shutdown where you need to do this only happens like once every millennium or whatever, not very often. Well, this guy had been gone for a year. It was his first day back, and he knew he had to pull this, but he forgot about the steam coming out, and so he didn't run fast enough or run at the very start, and that's why he got burned by the steam. And so there was a whole bunch of things in here, and a whole bunch of things that needed to happen, and this guy just...
With the elbow being one of them.
Elbow was a good idea, except you really don't want... the whole process is bad, right?
Yeah.
The whole process is bad. There's lots of things that need to be fixed here, and there's lots of similar incidents that could happen in different processes where there is no elbow, but they could have a better system.
You could have just told them arrangement placement, and he would have thought, oh, the elbow's right there in arrangement placement. It makes sense.
No, it wasn't a human error. Well, okay, I'm not going to go into the details this way, but it was crazy enough the way it was, and so I figured out. Well, now this doesn't mean you have better troubleshooting to do this, but other examples are you need better troubleshooting because you need the facts of why the equipment broke. And if you're one of the people who doesn't understand equipment all that well, having a guide to help you troubleshoot the equipment, or at least help you make sense out of what people are telling you, is helpful. And that was what I got when I got together with Heinz Block, and we took his troubleshooting tables, and we developed a course around it, and we computerized that eventually, and it became Equifactor.
All right, so we'll get into the Heinz block tables in a minute. I want to touch on this. What is like a typical equipment snap chart look like? What's like a normal, what does that first one look like that people almost always draw?
All right, bearing failed and the process went down. That's about all we have.
So it's pretty sparse.
It broke.
Yeah.
The incident, and right before it or right after it, sometimes they'll put, we found the component was broken.
Yep.
We recognize that's the problem right away with people. No information. And a lot of investigators, they're not experts.
Some are.
They're not. Well, I'm saying a lot of investigators, though, for safety incidents and things, they're not reliability experts. They're not equipment experts. They go, yeah, well, it broke. The guy told me the bearing failed, so I'll mark the bearing failure.
Well, this is a funny one. I gave a course at a big bearing manufacturer. I won't tell them which one it was. And I realized the examples I had in the course were bearing failures. And these guys were like the industry experts in bearing failures. And I'm teaching them how to troubleshoot bearing failures and how to make that into a snap chart and find root causes. So I was a little bit hesitant because I knew quite a bit about bearing failures, but I didn't know as much as these guys knew. And so I'm teaching, and we do our first example, and it's a bearing failure, and we get to the troubleshooting tables, and we go through, I don't remember why it failed, but we go through an example. And when we're done, they present what they found, and we have time for a break. And the guy who's the guru of the gurus comes up to me and goes, wow, that was really good. I know all this stuff, but I don't have a thing that has it organized like this and that I can make sure I don't forget to check something. And it's so systematic, it just really is handy to have the knowledge all organized like this. And I was like, whoa, this is really cool. Even experienced people, not just people who don't know what they're talking about, but experienced people can use a systematic process to get more reliable results.
So you mentioned the tables. So who is Heinz Block?
Well, Mark might better answer that because he's met him before. But Heinz Block is the one of the world's just gems of equipment troubleshooting, equipment expertise. Worked in petrochemical facilities all over the world for Exxon, troubleshooting all of the crazy things that they came up with in process equipment, all these failures, and some of these things took months and months to figure out. But he gained a lot of knowledge, a lot of expertise, and a huge bank of just how does equipment fail? What do we look for and see in the real world when I see, hey, this bearing seized or this bearing blew up?
And how do you prevent it too?
And then how do we fix it? How do we make sure it doesn't happen again anywhere else? So he kind of spent his entire career doing that, and That's what led to the partnership in the Equifactor.
And he's
side.
passed away now. So he was an engineer's engineer, right? And it was always funny because we'd be doing these classes and somebody'd ask a question and he would go off on this tangent on a detailed thing about some equipment design, and you'd be like, okay, that was off the but it was very good information always. It may not have been part of the course content, but Heinz had it in his head. And so it's really good to capture this information, in Heinz's case before he died, and make it into something that's going to survive him and be there. Just like today we've got examples of people who are getting ready to retire at facilities who've got this great information, and you need to capture it, and you can in Equifactor in a form of a troubleshooting table for specialized equipment, so that when that guru is no longer available to answer your questions, you can get the questions answered.
So Equifactor is a series of equipment troubleshooting tables. They look at specific things like specific types of equipment, pumps, motors, all the compressors, a lot of different specific equipment,
conveyor belts, all these things, all these industrial
turbines,
things,
transformers, fans.
It's also got what I would call more general things, every type of valve ever, and things like electrical components and physical components like bearings and different types like that. So it has this list of equipment. Under each equipment is a series of symptoms. So what is a symptom in Equifactor? What does that mean?
Yeah, so this is, hey, my pump isn't pumping enough fluid. This something that's happening out on your plant floor that it don't like it. Some way the equipment's behaving unexpectedly or it fails. So every way that a pump can fail is on there. Every symptom, it's not pumping enough.
In a pump, it could be the bearing seizes. It could be the mechanical seals fail.
Yep.
It could be, and you go say, oh, that's a symptom right there. And then you take that, and there's a list of potential causes, potential reasons why. Now, causes are not root causes. Causes are things like a mechanical seal might fail. We're just looking at this because it's got debris in the water that's flushing it that causes the seal to fail. And so you can find that, and then you go, oh, so we got to get rid of that debris, or we've got to find a clean flushing fluid. Boy, say that 3 times fast that you can use, and those kinds of things then become the information that goes on your snap chart, your diagram of what happened, to go from this, it was running, then it broke, to get to a much bigger story of what happened to cause it to fail.
Yeah. And so I always understand it to be, it's a physical cause of that equipment symptom. So it's not, this isn't root cause. It's not even necessarily a causal factor. It's the physical cause. You get down to that component.
It's getting pretty close to a causal factor in most cases.
And then you can look at what your causal factor might be, which is what's causing the debris itself.
Could be.
It could be something in your process broke that's allowing that debris to exist. And it could be those kind of things. Now, it might just be that there's debris that causes the failure because we never designed or accounted for it.
And the answer is, a lot of times when you start off, you know the pump failed. You find that the mechanical seal maybe had seized up. And now you're thinking, oh, what do I do? Well, obviously you're going to replace the mechanical seal, right? So the simple answer in the past has been, it broke, what do I do? Replace it. It broke, I replace it. It broke, I replace it. How many times do you need to do that before you say, there must be a better answer than just replace it, and all the downtime you have and all the cost involved in doing that. So that's when you start saying, well, you could say it's why did it fail? And the why is not, it's going toward this physical thing that happened that caused it to fail. So it's really simple. And when you can get beyond it broke, fix it, bearing seized, replaced it, bearing seized so bad the pump got damaged, we'll replace the whole pump. And once you get beyond that, you're starting to see, oh, there's ways we can change this so this bearing won't fail again for the same reason.
And I kind of think of this back to, and I what a strange movie to reference at this point, but you remember Sling Blade, the movie goes, the guy was like, I can't figure out why my lawnmower is not working. I've been checking all these things. Can you look it over? The guy goes, it ain't got no gas in it.
It ain't got no gas in it.
Oh, I do remember that.
Yeah, that's a core memory just unlocked in people. I haven't watched that movie since the 90s.
Ain't
got no gas in it. But that's the kind of thing, we look through these list of physical causes, and my lawnmower's not working. People are like, oh, I got to check the belts. I got to check all these different little.
Okay, I'll ask you if this has ever happened to you. Have you ever tried to start your car and you realize it's not in park? You turn the key, it doesn't work.
What's going on?
You look at gas, it's got it. Well, wait a second. It's not even the starter's not turning on. Maybe the wire's broke. Maybe there's no. You got it. You don't have it. You have it in drive or in reverse when the car's stopped, and you got to put it in park to start it.
And unless you had seen that happen before, I don't even drive an automatic, but unless you had seen that before, you'd have no idea to look for it.
Well, if you start it with a manual and it's in gear, you're going to have a different experience, right?
Yeah. But these are the types of things that we have in the Equifactor tables. If you put an engineer on an equipment failure, they're going to look for all the technical stuff immediately, and they're going to, they know a lot of these things to look for.
Hopefully they do.
You hope they do. Maybe you have somebody who's been doing it for 15 years and they know stuff. Maybe you have a fresh, mechanical engineering graduate. I've been there. That doesn't know anything of real world to ask. That's what should be in the Equifactor table. You put an engineer on that lawnmower problem. Look at all these things. Is there gas in it? All those human pieces that you're not going to see in a tech manual.
Well, same thing. A simple
they're in there.
A pump. It's got a strainer. Can't pump. Is the strainer clogged?
Yeah.
This is one of those simple things. Simple thing you can check. Or another one always is the valve open?
Yeah, the valve lineups.
Is the suction valve open? Oh, yeah, I should check that. Oh, darn, I'm an idiot. It's one of those I'm an idiot ones when you figure it out.
Yeah. So taking this information, taking these tables, we have a process. It's pre-built. It's got this information, how to do these troubleshooting quickly. What if we don't have a table, though? Maybe my facility has really unique equipment or a unique process it's a little, we have a pump, but this is a special pump that we had to have built for this process.
I don't know about special pumps, but we didn't have a conveyor belt one to start with. And one of our mining companies had miles of conveyor belts, and they said, we want a conveyor belt table. Well, you sit down with the expert and you see what are the symptoms of a broken conveyor belt. And then for each of those systems, you go back and you look at the basic engineering, and you figure out what are the things that could go wrong that would cause that symptom. And it does require knowledge. And that's why you get the experts involved and the people who use the equipment involved who've seen failures in the past and know what they are. And you collect that information, and that way that information is there forevermore. So that anybody comes along and says, car won't start, one of the things you're going to check on is it's in park. And
that's the first thing you check. You don't
be.
go look at anything else, like the most basic low-hanging fruit.
So it may be, and when you're troubleshooting a car, there's the electrical system failures and the fuel system failures. We're not to the fuel system failures. We can't, the electrical system won't work. It's not cranking the starter motor over. What makes the starter motor turn over? And you can say, well, it could be the dead battery. No, it's not that. I got headlights. It's all. Yeah, but there's an interlock that keeps it from starting when it's in gear. So you got to put it in park or neutral.
All right. So if they want to learn about Equifactor, what's the best way to learn?
Talk to me. I run the Equifactor program now, and I sit down with people all the time. Here's how to use it. Here's where it's at in TapRooT. Here's where you can find all those tables we've already built. Sit down and build a whole bunch of tables with you. I don't have every piece of equipment in Equifactor.
And maybe even come to one of our public courses. I know we have Equifactor public courses on the calendar. Check those on our store page. The link is down below.
We've got them both in Spanish and English.
Yep. And there's also a specific Equifactor tab on our website. Again, you can find that link below. And that's got a lot of different things for helpful resources I know you put together for Equifactor. So those are two great things. Now, I'm a lowly mechanic.
You might mention there's both virtual training and live training for
in-person,
Equifactor.
Well, they're both live. It's just in
I
person
guess
or
right.
virtual.
In person or virtual is a better way to say that.
Both with a live instructor. Now, I'm a lowly mechanic.
You are?
I'm a lowly mechanic. How do I actually use this stuff in the field? What is my ability to use this while troubleshooting in the field?
Yeah, so I got my list of hey, what am I seeing? How is this thing failing? Oh, okay, I'll look down. Here's a symptom. Here's everything I ever need to look for.
And I've got that in a big book I carry around, or is there somewhere?
You could have a big book.
I could have a book.
We have that in a book. Probably what you're going to have is your phone. Everybody has their phone. And you get into the TapRooT app. All those Equifactor tables are right there. So you can just pull them open. Hey, here's what I'm finding.
Or you
click.
get on the
There
laptop
we
back
are.
in the office, you pull up what the symptom is that you're exploring for this broken compressor, and you make a table out of that. And you take that table and you say, okay, which one of these symptoms, or the symptom I've got here, which of the things that are listed can I check without tearing down that compressor? Like if there's a filter, can I check it? Is there valves that could be shut? Can I align them? So you check the things first that are going to be the simplest to fix. Sort of like, do I have gas in the tank and is it in park?
Is it plugged in?
Yeah.
Does it have power?
Is it plugged
Is there a
in?
breaker?
All those good things. So that you get those first. When you get those done, then you're going to get to the point where you say, oh gosh, I got to tear this thing apart. What should I be looking for while I'm tearing it apart?
Yeah.
What do I need to look for when it's torn apart? What do I need to look for as I reassemble it? What do I need to look for when I reinstall it? Because any of those things could be causing these problems. And so you make yourself a list, a little checklist out of what's in the troubleshooting table, and you're ready to go. And that way you don't get it all put back together, and you don't, a month goes by and it fails again. You go, well, darn, I thought I had that fixed. I wonder what it was I didn't fix, because you went through systematically and checked those things off.
All right. So again, if you want to learn more about Equifactor, check out the link below for the upcoming Equifactor courses. We've got them on our calendar. So sign up for one of those. I think Justin will be the instructor, so you can say hi to him and have a good time there.
And if they have any questions, they can call him.
Yep. And I think the next in-person public course we have will actually be at the TapRooT Summit. So check out, again, link below for the summit. I know registration is open for that now, so
One
check
more
those
thing,
out.
if they want to find Justin on LinkedIn,
Yep.
why don't you put your LinkedIn?
You can comment it on the video.
LinkedIn
Profile
profiles
down
going right there.
Yeah. That way they can get a hold of him.
Yep. All right. Well, thank you for the TapRooT podcast. We'll catch you in the next one.